Today we're going to find the length of a triangle with the given measurements here. Here's my triangle to the left. Of course, it's a right triangle. The angle theta is 60 degrees, and we're trying to find x and y. Now we're using our trig function relationships. For example, the sine of theta is what? You know it by now? The opposite over the hypotenuse. These are the triangle relationships we're going to use, and you can see that we have a 60-degree angle, which is one of our special angles. So now to find y, for example, I would have y is, first of all, let me explain this, opposite to the angle, so that would mean I can use the sine function. The sine of 60 equals, in this case, y over the hypotenuse, and the hypotenuse is 18. That's how I find y. To find x, x is the side that is adjacent to the angle of 60 degrees. Adjacent over hypotenuse, we all know, is cosine theta. So the cosine of 60 degrees is equal to x over 18. Now, I do not want to use my calculator. Remember, I always say in class, draw a triangle for our special angles. Let's take a look at a 60-degree triangle. That is one of our special angles. If we have 60 degrees here, then this angle must be 30 degrees. What is the relationship that we've been talking about for days now? This side opposite to 30 degrees is 1, 2, square root of 3. This is the triangle you definitely need to memorize, and I'm going to use this relationship to find x and y. Okay, first thing I'm going to do is I'm going to solve for y here, so that means I'm going to multiply by 18. 18 times the sine of 60 is equal to y. Now, if I look at my relationship of my special angle 60 degrees, the side opposite to 60 degrees is the square root of 3 over the hypotenuse, which is 2. So we multiply 18 by square root of 3 divided by 2. Well, I can squeeze it in here. We can reduce the 2 with the 18. That gives me 9. And the y value is 9 square root of 3. So y is equal to 9 square root of 3. We have no units here, so we just say units. Okay, now let's find x. Again, to get x by itself, we're multiplying by 18 both sides. We have 18 times the cosine of 60 is equal to x. If I look at my special angle triangle, the cosine of 60 adjacent, this is the side adjacent to 60 degrees, so that would be 1 divided by the hypotenuse is 2, and that is equal to x. Of course, we can reduce. 2 goes into 2 ones, into 18 9 times. So x is equal to 9 units, and that is how you find the missing sides on this particular triangle. Okay, here's one more. This time, another one of our special angles. This time I have 45 degrees. So again, before I set everything up, let me draw my special 45-degree triangle here. 45, 45. The sides opposite and adjacent are 1, and the hypotenuse is the square root of 2 for this special triangle. So now that I have that, I'm going to use my trig functions to find x and r, the hypotenuse. So the side x is adjacent to the angle, and if I use adjacent over hypotenuse, I have two variables, which is not good. That's not going to help me. So I got to figure out to use a different trig function where I only have one variable. Let's take a look what side is given. We have the opposite and we have the adjacent. Remember what kind of trig function that is? I'll give you a second. Yes, it's the tangent. So the tangent of 45 degrees is opposite divided by adjacent, in this case, is x. Okay, to find x, multiply both sides by x. X times the tangent of 45 degrees is equal to 20. And to get x by itself, we have to divide by the tangent of 45 degrees. So let's take a look at our special angle triangle over here. The tangent of 45 degrees is opposite over adjacent, so in this case 1 over 1, which is 1. So x times 1 equals 20. I don't really have to write the 1, but that means that x is equal to 20. There you go. Beautiful. Okay, x is 20 units. Now to find r, I guess I could use a trig function, but I don't even have to. Why not? Because I have a right triangle here, and I can just use the Pythagorean theorem. A squared plus b squared equals c squared, or in this case, r squared. So we have 20 squared plus 20 squared equals r squared. 400 plus 400 is r squared. 800 is r squared. Okay, we have to take the square root of both sides and simplify as much as we can. We have 400 is a perfect square times 2. I can factor 800 into 400 times 2. The square root of 400 is 20. The square root of 2 cannot be simplified, so 20 times square root of 2 is equal to r, which is the hypotenuse. So in this case here, for right triangles, we used the trig functions and our special angle relationships in order to find the missing sides.